welcome to my series on how to get a job in tech without a CS degree. I'm going to give you a guideline on a bachelor's in computer science to make you just as good as anyone who has one. I will say before I get started, this is going to be geared towards people who are very interested in engineering. I do know that some tech roles may not need this much knowledge, but for sure, if you're interested in working with software, you need to start by following this guideline. By the way, please don't be overwhelmed if you have no idea what I'm talking about. That is perfectly fine. I will link multiple free MIT courses that covers each topic that I go into in this video. All right, first core topic, programming. Bet you didn't see that one coming. So there's this huge debate on whether or not you should start with Java, C++, or Python. What I will tell you is that if you know all of these languages or all three of these languages that I listed, you know any language that's out there. So once you got these three down, you're good. For an anecdotal experience, I actually only knew Java and C++. I never really worked with any other language when I went into my first job. And then I picked up Python and C# within just a week. If Java and C++ are a bit too overwhelming for you to start with, it's perfectly fine to start with Python. In fact, the course that I'm linking uses Python in its introductory courses. So after this part, it's going to get really conceptual from here on out for the whole video. The first conceptual topic that I'll talk about is object-oriented programming. This is still under the category of programming, I'd say, is a core topic of this computer science bachelor's degree. Object-oriented programming is already talked about in the course, or the first course that I linked below. I'll also link a how-to video on understanding object-oriented programming in less than 3 minutes below as well, created by me. Now, I will say this next topic, it's probably the hardest topic of all of computer science. Sorry to kind of start out tough here. And this topic is data structures and algorithms. I will say that it's only truly hard because there's just so much content. This component has its own course, which even some of the content of data structures and algorithms is talked about in the introductory course that I linked. But there's another course that's entirely dedicated that does a review on some of the stuff that you learned in the introduction course that I linked. But there's also an entire course just dedicated to these concepts, which is linked in the second link below. I'll put tags for all these links. And with data structures and algorithms, this isn't something you can just kind of read about once or twice. No, you need to know this at the back of your hand for any technical interview you will ever have. Honestly, this is something that you're going to keep revisiting probably throughout your entire career until you retire. To get a really good understanding of this is probably going to take the longest. This is what turns that 2 years I mentioned into maybe even 3 years. And don't feel discouraged at all. Again, if you find interest in this stuff and you want to be a forever student, there you go. You can never stop worrying about data structures and algorithms. But don't feel stupid. This is just a huge topic. So much to talk about. And the algorithms that are gone over in the course that I've mentioned and what's usually brought up in interviews, those are just kind of general algorithms. They're not like, there's still a whole other, you can get a PhD in algorithms. Like it's a huge topic. Don't feel stupid. All right, we're finally moving on to the second core topic of the computer science bachelor's degree, discrete mathematics. I'm not gonna go too in depth here. Actually, discrete is brought up in the courses that I already linked, so it doesn't even get its own link. But math is a huge part of computer science. I will go over the main concepts that you need to know, at least what they are from discrete mathematics, which the main concepts are big O notation, logical deductive reasoning, and graph theory. Now, logical deductive reasoning, that is something that you're basically taught immediately as soon as you have a general understanding of, just what does an and mean, what does an or mean, what does a nor mean, all that stuff. There's also more logical deductive reasoning from there. Discrete mathematics goes a lot more in depth than that. Graph theory, I don't recommend learning about that until you have you're basically at the level of trying to learn about data structures and different types of data structures. Now, I'm kind of just blabbering here about these concepts, but what I mainly want to address is big O notation. That is something that is brought up in every interview that you'll ever have for the technical component at least. You'll be asked on the spot what the time complexity and the space complexity of a program will be in the middle of the interview, and this is big O notation. I might have just terrified you with that, but once you take the courses below, and like I said, these are courses I'm recommending that are free, but there's other courses too that cover these topics. And once you take all these courses and whatever bootcamp you're interested in and gain a better understanding of all these topics, you'll get a better idea of how we apply big O notation to different programs. And to simply define big O notation, it's just the amount of time it takes for a program to run as the amount of data grows. And again, if you've never done all these things, never heard of these concepts before, this will sound like mumbo jumbo. That's fine. It's okay. But this will make sense to you once you get the other concepts I mentioned so far. All right. The third core topic of our degree that we're getting for free right now, operating systems. The main concepts you should understand of operating systems are interrupt priorities, scheduling, memory management, virtualization, and then finally the relationship between the user and kernel interface. I think I'm just starting to sound like I'm speaking an entirely different language at this point. That's fine. For operating systems, I definitely don't recommend learning about this until you take at least the 2 other courses that I posted so far. This is definitely a bit more of an advanced topic. Honestly, usually in colleges, they don't do this course until someone's a junior or senior, if that gives you a better idea of where about you should be learning these concepts in your career. Another thing to point out here, operating systems is not just those topics I mentioned at all. Operating systems goes way more in depth. I mean, you're answering the question, what is a computer? That is operating systems. There could be so much more you can learn about this. It's entirely up to you and your interest. Honestly, and when I took my courses in college, this was my favorite class. So this is very interesting to me. You might think this is crazy complicated. I don't really care that much. That's perfectly fine. And that's why I came up with those general concepts that you get or what you should know from operating systems. In case if you're not really that interested in knowing everything about the operating system, you should at least know those concepts. Why should you know about those concepts? Because they're a key component in the debugging process when you're working on an end-to-end project of some kind. You should also know in general how a computer works and what a computer is. So you should understand what an operating system is, so you know exactly what is going on with your program. And another huge part, speaking of, which I'm gonna roll into the 4th topic and final topic, networking fundamentals. This is part of understanding what's actually going on with your program. The only real thing I'm gonna talk about here is the OSI model, and this is something you can get a PhD in. You could go way in depth with this knowledge. You can go to school for this for 10 years. Like, there's so much to know about this. But if we're here just to figure out what you want to do as your technical career, the OSI model is actually a good start. I actually think when you look at the OSI model, each layer that you have in the OSI model indicates what job you may be interested in. Every software job depends on one of these layers, anything out there. And you don't need to know the OSI model, the entire thing by heart. You need to know your layer that you're interested in, and you need to deep dive into that layer, really. As you can see here, each layer has a corresponding job to it. Now I'm going to ask you to do something for me. Look at each of these layers and see what jobs pique your interest, and see where it lies in the OSI model, and see how that relates to the overall OSI model. And again, or really just to point out, us computer science college graduates, we did have to take an exam and go through and read a bunch of textbooks on the OSI model and networking fundamentals. And that's something that is really useful to know, yes. And you should know at least what these layers kind of are, but it's really not necessary. What's truly, truly necessary is again that layer you're working on. And there we go. We went through all the computer science topics that are what make up a bachelor's degree, but I'm gonna go into some bonus topics depending on your interests. I definitely recommend going into at least one of these. First, we have databases, web development, signal processing, microprocessor applications, and digital logic. I'm gonna include links to different courses for each of those topics below. I really hope that this guideline makes things easier for you, especially if you have no idea where you're going and trying to learn about in the tech field, especially if you have no idea on what to learn and you really want to learn, but you just have no idea what to do. I hope this guideline helps you. And let me be honest with you, if you know all these concepts I just said, you have a bachelor's degree in computer science. Like, I'm not even joking. This is what it is. Please like and subscribe if I helped you out today. And good luck on your journey on becoming a software engineer.